Hi, class 10 boys and girls. Today we are going to discuss about the rational numbers. Irrational numbers again. This is the last video of this chapter 1. And about the rational number. Rational number is a number whose decimal expansion is either terminating or non-terminating recurring. There are two cases. Either terminating or non-terminating recurring. An irrational number is a number whose decimal expansion is non-terminating, non-recurring. Non-terminating, non-recurring. We will discuss about these two cases about rational numbers. Rational number is a number of the form p by q, where p and q are integers. For example, 3 by 4 is a rational number. Then 15 divided by 1600. It is another rational number. And 3 upon 4. 3 upon 4. 3 is, you can change it into decimal form by division. 3 is dividend. 4 is a divisor. Here, divisor is greater than dividend. Therefore, 0. Then put a decimal point after putting extra zeros. In 4, how many? In 30, how many 4? 7 into 4, 28. Subtract 2. Again, write one more 0. In 20, how many 4? 5, 4. 20. 0. Now, 3 by 4. 3 upon 4 is equal to 0.75. Here the decimal expansion of this division process ending, terminating. And here we will say the decimal form of this rational number 3 by 4 terminates, terminating decimal form. But another case, this is also 15. 15 divided by 1600. When you are dividing this 15 by 1600, you will get a terminating decimal expansion. In order to divide this number by this number, whether it is terminating or not, we can identify by a shortcut method. That method is first take a q. This is p and this is a q. Only take a denominator 1600. Factorize it. 2, 800, 2, 400, 2, 200, 2, 100, 2, 50, 2, 25, 5, 5. Now 1600 is 2 raised to how many? 1, 2, 3, 4, 5, 6. 2 raised to 6 into 5 square. And this q you can, denominator you can write as the prime factors of 2 and 5. 2 and 5. When you are dividing 50 divided by 1600, surely you can see this decimal form is terminating. How do we know this decimal form is terminating? Check the denominator. If it is only factors of 2 or 5 or both 2 and 5, the decimal form will be terminating. Maybe factors of 2 only, factors of 5 only, or both 2 and 5. Then decimal form is terminating. Otherwise, other than this 2 and 5 as factors, non-terminating. That to explain that fact, we have one theorem, only statements. Let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to m into 5 raised to m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. And this is the case in which a rational number without a division, we can identify whether a rational number is either terminating or non-terminating recurring. If the denominator or q has only factors of 2 or 5 or 2 and 5 both, in such cases, the decimal expansion of that rational number p by q form will be terminating. To illustrate this to explain this idea in a different form, I will give an example. I will give an example for a terminating decimal form. 13 divided by 3125. 13 divided by 3125. And here 13 is P and 3125 is Q. Let Q is equal to 3125. When you are dividing 13 by this number, it is a rational number. But this rational number has a decimal form or not, which is terminating. We can identify easily by making prime factorization. 2 is not possible, 3 is not possible, 5 is possible. Then you will get a and 3125 we can make a prime factors like this, that is equal to 5 raised to, how many 5s are there? 5 raised to 5. And here, according to this theorem, whether it is terminating or non-terminating, here we can write 2 raised to, there is no factor 2 raised to 0 into 5 raised to 5. Here n is 0, m is 5. This is a terminating decimal expansion. This is a question from exercise 1.4, question number 1. Okay, 1.4, question number 1. By making prime factors of this denominator or out of p and q, factorize denominator and check whether it is factors of 2 only or 5 only or both 2 and 5, and check whether it is according to these statements, according to this theorem. Here there is no 2 factor, that is why we will write 2 raised to 0, and there is a 5's are there, we have to write 5 raised to 5. Therefore, in this question, the rational number 13 by 3125 is terminating. 3125 is terminating. By this theory topic, the chapter 1 is over. Only now we have only exercise questions to solve. Also, a particular specialty of these videos, I will give all the CBSE question paper questions of last 10 years through these videos, plus all the exercises of test book. Then nobody shall get any fear about examination. A sure pass, you can score a sure pass in any examination, whether it is a periodical examination or a board examination. Okay, thank you.